Sir, we are live now, sir. Please start.
Hello, everyone. Good evening. This is your instructor, Balaji Srinivasan. I'm really happy to join you on this live session. So hope you can, use this opportunity to interact with me. If possible, we'll try to do this on a weekly basis so we can actually have almost weekly interactions, but that certainly depends on whether you're able to engage me with questions relevant to the course and so on. So we'll see how this works, but let's just get started with this. What we are really looking at is, there are different ways of engaging you on this online course. Of course, this cannot be as good as a real classroom lecture. So now you are having to view these lectures and then find a way to interact with me. One primary way of interaction is the discussion forum. So you could put in your questions at any time as and when you think of a question, even during the live sessions. I mean, even during while you're watching the video, you probably have some questions that are coming up. So if you can just jot it down and put it on the discussion forum, that would be a primary way of actually having this interaction. As we discussed in the discussion forum, we have one TA assigned to monitor the discussion forum almost throughout the day. And at the end of the day, I also get an abridged version of whatever discussion is happening on that particular day. So I should also be able to go in and answer your questions. So please use that opportunity to shoot your questions and start a discussion off. That is the primary avenue. But then the secondary avenue here is through this live session. So whatever questions you're not able to get answers in a satisfactory manner, any unresolved questions, or if you have any further questions beyond whatever you already asked in the discussion forum, you can actually do that through this live session, right? So that is the whole objective of this particular session. There is, I know, an issue with the timing. So I'll tell you why I chose this particular time for this first interaction. One, I did not want it to be during your regular work day. So it shouldn't be something that comes with whatever else you're doing. You may be working somewhere, you may be teaching at some place, you may be taking a course at some other college and so on. I wanted to stay clear of that. So that's why we are having this session at 5:30. Maybe this is not late enough. You want to have a session, say, even later at say 6 o'clock or maybe even after 8 o'clock. If you just give me your opinion, we can discuss that and we can arrive at a time. So the timing is still open. And I also chose Monday because typically the weekly assignment submissions are happening on Wednesdays, right? So I thought maybe if we have this a couple of days earlier, that would help. Once again, if you say, during the weekdays, throughout the day, something else is happening and you're not able to participate, you'd like to have it during the weekend, maybe a Saturday or even a Sunday, if you just tell me your opinion, we'll certainly consider that and see if we can make that happen. Okay. And of course, it'll have to be some sort of decision which doesn't affect others. So we'll have to, bounce it off other people also in the discussion forum and come to a conclusion as to when to meet. Okay. So that is one part. The other part is, of course, get a feedback from you on how this course is going. whether this is actually meeting the requirements for you professionally and also academically. Uh, this is what you are expecting to see when you actually signed up for this course. So from that perspective, if you notice the first week of lectures, it was from a presentation, right, that I put together, which covers the entire course, right, right from what we start with the why optical fiber sensors, what are the basic configuration of an optical fiber sensor, and then moving on to different issues, different types of optical fiber sensors, amplitude, phase, wavelength modulated and polarization modulated sensors, with distributed sensing also wrapped into all of this. So that's what I was trying to give in the first week, just give you a complete overview of what you will see in the course, give you a flavor for what you will see in the course. And hopefully that gave you some idea. And I am sure that several of you thought it was a different type of course and you enrolled, and now you're finding out that this may not be the right course for you, which is fine. So you can possibly take a decision to not continue with the course and so on. But for those who want to actually continue with the course, I do strongly suggest that you do this on a weekly basis. Like we're talking about releasing 3 videos, right? So you try to watch these videos, um, you know, on different days, but on the same week that it's released, and also participate in the assignment as and when we release these videos, not hold off until just an hour before it's due, do the assignment and all that. um, Clear idea is that if you are able to take up the assignment problems early on, you have an opportunity to interact with us. You have an opportunity to put up your question in the discussion forum. Uh, it could be as much as, oh, I don't know where to start with this question. Can you help me with this, right? So and if we think it's appropriate, we will provide you some tips as to how to solve it, right? So the idea is that we learn together. It's not so much about the marks and all that, but it's about imparting knowledge, and we find a way to learn together as we move on with the course. Okay, so so that aspect, hopefully you're fairly clear about at this point. And any questions once again on that aspect, the content of the course, any questions you have at this point, you can feel free to shoot it during this interaction session, or maybe even offline through the discussion forum. I've not actually checked how many people are present in this live session. So I see that about, let's see, I'm not actually seeing, 11 people here. So just one second, I'm just hearing an echo, so maybe I'll just try to, pause that. Okay, fine, this is better now. So so this is clearly a very small representation of the number of people that are enrolled in the course, which is beyond 1,000 as I speak. So I know I'm not able to interact with a lot of you, but like I said, we can look at possibly moving this interaction slot to some of the slots, see if more people can get on with this. Okay, so so that's sort of the background of what this live interaction session is about. So let me actually go into some specific questions that were posed. There are several of you that had filled out that form, which is soliciting questions from you, and several of you actually said you don't have a question at this point, but anyway, thank you for filling that form. But there are a couple of questions that I could possibly take right now. So one question is about can multimode fibers be used instead of single mode fibers for fiber Bragg grating sensors? So this is a question that is related to the presentation that I did, in the week as part of the week 1 lectures. And if you remember, I had talked about wavelength modulated sensors, and in wavelength modulated sensors, I had introduced this concept of fiber Bragg gratings, using fiber Bragg gratings for for realizing wavelength modulated sensors. So the discussion there was primarily about using a single mode optical fiber for those sensors. So the question that has been posed is, can we possibly use multimode fibers instead of the single mode fibers? And let me actually pick up that corresponding slide and try to answer this question. So let me first share my screen. Hopefully my screen is visible. And let me go to that particular discussion that we had on fiber Bragg gratings. Yes, I think this is the right slide. So if you look at a fiber Bragg grating, one second. Yes. So we are talking about using an optical fiber with a core and a cladding region, right? And we're talking about launching light in the core of the optical fiber, which is interacting with this periodic change in the refractive index, right? And through this Bragg diffraction, you can also you can say that only one wavelength is going to be reflected back, and then rest of the light is going to be transmitted, and that reflected wavelength is given by 2 times n effective capital lambda, right? So now I mentioned that this is typically happening in a single mode optical fiber. But what happens if you do the same in a multimode fiber? Okay, so what if the core of that optical fiber is multimoded instead of single moded? It supports multiple modes. In that case, if you see this in this expression, it actually has n effective. The n effective corresponds to the refractive index that a mode sees, the effective refractive index that a mode sees as it's propagating down this waveguide. So when you have a fiber Bragg grating in a multimoded fiber, the capital lambda is the same, right? That is not changing, but n effective can be different for different modes. And if it is different for different modes, then the Bragg wavelength at which this Bragg condition is satisfied, that is different for these different modes. So what you would see in the reflected spectrum, when you look at the power as a function of wavelength, is not just one peak, but you will see multiple peaks corresponding to the different modes. Okay. So the effective index of higher order modes are going to be lesser compared to the fundamental mode. So correspondingly, the the Bragg wavelength or the peaks corresponding to the different modes are going to be showing up in the lower wavelength side of this spectrum. So yes, that is actually a very powerful way of doing sensing as well, because some of these strain coefficients that we are trying to pick up, this in a single mode fiber, you are only picking up the longitudinal strain. But if you are going for a multimode fiber, you could potentially pick up strain components in the transverse direction as well. Okay, so that could be adding a lot of value if you do this in a multimode fiber. However, I should also mention that the detection becomes more complex, or the analysis of the reflection spectrum becomes more complex in that sense. You have multiple peaks, and then you're having to analyze the changes in each of those peaks. So, there is certainly some challenges related to that, and each of the peaks may not be of the same amplitude. The one corresponding to the fundamental mode may be stronger compared to some of the higher order modes. So there are a lot of detection challenges in that case. But if you are able to overcome that, then yes, this Bragg rating in a multimode fiber can add a lot of value to the sensing aspect. Okay, so that's the answer. So hopefully the person that's asked this question, they got what they want. Okay, so now I will go to another question that we have here, which is, what is the difference between an acoustic phonon and an optical phonon? So we discussed this in terms of Raman and Brouillon scattering in optical fibers. This is once again something that we discussed in the first week of lectures. So let me just go to the corresponding slide and explain this. So first, let me explain what we mean by an optical phonon, and then I will go to the acoustic phonon. So an optical phonon, what we are referring to is when you have an electromagnetic wave interacting with molecular vibrations. Here, a molecule consists of two atoms sharing a common bond. So it's represented as if there are two masses connected by a spring. So the masses can move around their mean positions, and then that actually sets off a vibrational mode, which is what we're calling as a phonon mode. So the interaction of an electromagnetic wave, which is this light wave, with these molecular vibrations is what we are calling as an optical phonon. And a corollary of that was basically saying that, okay, when the interaction happens, the scattered light could be either with lower energy, as in the case of Stokes scattering, or higher energy, as in the case of anti-Stokes scattering. So based on the relative intensities, you can potentially estimate the temperature at which this particular location is, the temperature that this location is subjected to. Okay, so we were talking about this anti-Stokes Raman thermometry. But the key point relevant to the question that was asked is that we're talking about interaction of light with molecular vibrations. Now, if we go to the other part, the acoustic phonons. The acoustic phonons, we discussed that with respect to these Brouillon distributed sensors. So I'll just go into this related slide. Right. So when we have light wave that's actually coupled into the, let's say this is the core of the optical fiber. In the fiber, the fiber, of course, is consisting of all these atoms and molecules, primarily made of silica, right? So the silica molecules, they're all actually moving around in their mean positions at room temperature. If you're talking about a temperature of 0 degree Kelvin, then everything is frozen. All the atoms are all sitting in whatever positions they are in, but they're not moving around their mean position. But the moment you subject them to some temperature, they start moving around their mean position, and that's what causes these vibration modes, right, which we're calling as phonons. But in this case, when we're talking about acoustic phonons, what we are talking about is not just one molecule moving, a collection of molecules, they're all moving. So it's like as if the entire matrix is getting agitated. Okay. And of course, you cannot visualize it, you cannot physically see that, because you see this solid object, like this, and you see that everything is like completely static in this picture. But the moment you actually go into the microscopic, you start looking at this material at a microscopic level, you will start seeing that all these atoms and molecules that are constituting this material, they are not really just static. They are all moving around their mean position, and the matrix as a whole is getting agitated. Okay, and that agitation or that vibration of the entire matrix in a macroscopic scale is what we are calling as acoustic phonons. And specifically when we're talking about this Bruin scattering, what we are talking about is when electromagnetic wave goes through this material, it can bounce off these this entire the entire glass matrix vibrations, and those those vibrations can scatter off light in several directions. I'm just showing here that the vibrations could be oriented along different directions. So correspondingly, the scattering can happen in different directions. But typically in an optical fiber, especially if you're talking about single mode optical fiber, the scattering, the backscattered light is what we are interested in. And we do have a component that's going back and then interacting with the incident wave, and then that sets off a standing wave pattern. And then through the process of electrorestriction, we said we actually get a periodic change in the refractive index, and then that can actually strengthen the backscattered signal. It's a process what we call a stimulated Bruin scattering. Okay. So and we talked about very briefly, we talked about how that can be used for picking up perturbations along the length of the fiber. But don't worry if you don't understand a lot of this terminology, a lot of these concepts also, because the idea is not to teach you this concept right now. The idea is just to give you a flavor for this. We will go back and look at these concepts at a much deeper level later on in the course, towards the end of the course actually, when we talk about wavelength modulated sensors. So so yeah, no worries if you don't understand everything that I'm saying, but whoever asked that question is hopefully getting the answer they are looking for. Okay. So let me just go back and check if there are any other questions. Yes. Okay. So there is one question that just came right now in the last few minutes. So we have one question. Excuse me. Yeah, one question. How can we get the phase response of FBG? Okay, that's a fairly advanced question right up front. So as we talked about with the fiber Bragg grating, the slide that I just showed, we were looking at the spectrum of the fiber Bragg grating. So we are primarily looking at the amplitude or intensity of light as a function of wavelength. So the question is, how can we get the phase of that backscattered light? Now, this is actually something I'm not sure why we would want to get the phase response. That is one primary question. What is the sort of motivation for looking at the phase response? But if you want to get the phase response, the way to do that is to whenever we'll talk about this more when we go to phase modulated sensor. Whenever we want to make measurement of phase is always defined with respect to a reference. Okay, so you need to have a reference wave. Okay, so you need to basically beat this backscattered wave, this light that's scattered from the fiber Bragg grating with that reference wave, and then we can actually talk about what is the phase response due to this back reflection. But like I said, this is a fairly advanced question at this point. I would like to revisit this question and maybe at a later point when we go into phase modulated sensors. We can discuss this in a little more detail once you have seen some of those videos, some of those lectures. We can revisit this question. Okay, so the second question is for a fiber Bragg grating, how the periodic order changes in the FWHM of fiber Bragg grating. I'm not sure I completely understand the question, how the periodic order changes in the FWHM of fiber Bragg grating. So let me just try to see what could be this question. So let me just go back to the fiber Bragg grating and let me just try to see what I can perceive the question might be. So when we are talking about this interaction, this Bragg condition, lambda b equal to 2 times n effective times capital lambda, we are talking about the first order interaction where m equals to 1. Okay, so now you could have this interaction happening for higher orders also, for m equal to 2, m equal to 3, and so on. So m is actually what I'm referring to is, this condition on the left hand side, it's satisfying m times lambda, right? So where m could be 1, 2, 3, and so on. So the resonance condition will be at let's say 1550 nanometers, but when m equal to 2, that resonance condition corresponds to 1550 divided by 2, which is 775 nanometers. So you will have second order interaction and then third order interaction and so on, right? So which will produce peaks at different Bragg wavelengths. I'm guessing that's what this person is asking about. But in that case, the question is, how does the FWHM or the width of the reflection spectrum? So if I go further, so this reflection spectrum has got a particular width. So the question is, how does the width change as you go to other orders? Well, there will be a change because the phase matching condition changes, meaning the why we have a particular width here is because of the fact even when you're going to a wavelength that is slightly outside of this, slightly, from the center wavelength. Center wavelength is lambda b, but even if you go slightly outside of the center wavelength, you will have this. I'm just trying to switch off my phone. Sorry about this. Okay, you will have this, constructive interference condition that is satisfied, not completely like what's giving you this maximum power, but it is satisfied partially. And so that's why that explains the shape of the spectrum. Now, if you go to a higher order interaction, that shape will change. So it will most likely be broader than this, because the detuning for that case will be less constrained for that higher order interaction. So but it will certainly be different from the spectral width that we are looking at, the FWHM of that we are looking at. Okay, so hopefully that is what this person was asking about. Hopefully I addressed this question correctly. Like, there is certainly a chance that I might not have understood your question properly. So if that's the case, I would suggest that you follow this up with a question in the discussion forum, and I'm happy to continue this discussion there as well. Okay. So let me move on to the next question. It's about how can we write chirped FBG. So this person, I am guessing, is somebody who's doing research in this particular area, and so they are very interested in deeper level questions, which is absolutely fine. But I just want to make sure that some of the other learners, as far as this course is concerned, hopefully they are not getting discouraged by these questions, because you shouldn't be thinking that why am I not asking this question. I am fairly sure this person is asking these questions because they have been doing much more work in this area compared to you. But if you're not asking those questions, it's absolutely fine. You're going to be doing well in this course, even if you don't ask such advanced questions. Okay, so don't worry about that. Now, let me just go back and address this person's question once again. So when we talk about chirped FBGs, what are we talking about? We're talking about this. In this case, I'm showing as if the period of this index change is actually uniform along the length of the fiber. If it's lambda here, it's capital lambda here as well. Okay, so that is what we call as a uniform fiber Bragg rating. But the question is, what happens in the case of a chirped fiber Bragg ratings? Chirped rating is one where this capital lambda is not having a uniform value along the length of the fiber. It is some value over here, and it's some other value over here, some other value over here, and so on. So if we can go back to this expression, if capital lambda is a function of z, let's say this axis is along the we're denoting by z. If capital lambda is changing along z, then lambda b also, you can imagine, is going to get modified along z. So lambda b will be changing with respect to the longitudinal direction. And if lambda b is changing, you can imagine that there are like multiple resonances that are close to each other, corresponding to each location along the length of the fiber. So the whole spectrum will be broader compared to the spectrum that I'm showing here. So that's what we have in a chirped fiber Bragg rating. And you can make that chirped fiber Bragg rating by we modify the refractive index by using ultraviolet radiation. Why we use ultraviolet radiation and all, these are details that I'll go into in week 9 of the course. So we can come back to that at that time. But we use ultraviolet radiation. We use two beams that are interfering with each other to create this periodic pattern. But if that interference condition is modified slightly so that you have one beam that is collimated, but the other beam is slightly diverging, that will cause interference condition where the period of the interference changes along the length. So that is one of the ways you can possibly fabricate a chirped fiber Bragg grating. But like I said, it's something that's much more advanced than where we are at right now. So I will stop with just that explanation. But like I said, we can take this offline and discuss that in more detail, and it'll probably be more appropriate to discuss this after you have seen the lectures for week 9. Okay. All right. So I see that there is one more question that is coming up. So just the last few minutes. Can we use this fiber Bragg grating sensors for monitoring the temperature changes in a solar panel? Absolutely. Yeah, that's actually an excellent way of monitoring the temperature at solar panel. So it's I think it's fairly well known that the solar panels work very well when the efficiency with which they convert light to electricity is better if the temperature is relatively lower. So it will be making a lot of sense to look at the temperature profile across a solar panel, and yes, fiber Bragg gratings are a very good way of monitoring the temperature. So and if you have questions on how to incorporate fiber Bragg gratings in your solar panel, we can discuss that offline. Okay. So those are all the questions that I'm seeing on this through this form that you filled out. So let me just go to this live window and see if there are other questions that we have. And I see there is good activity there. There are some questions, and also the TA Jagdish has been very active in trying to guide the discussions. So I think most of the discussion, there's something about the textbook, and Jagdish has pointed out. In fact, I would say that at this point there is no good textbook for this type of a topic. Most of the books that you see in this area are more of reference books. So what is the difference between a textbook and a reference book? Well, textbook is when you have all these things are explained from a very basic level and moving up to more advanced levels, and there is a lot of problems that are posed and solutions provided for those and things like that, and it's aligned to the material that we are teaching in this course. Unfortunately, that's not what we have. In fact, there are some plans to possibly write a book in this area as well. So there's some good ideas which might happen in the near future. But unfortunately, right now we don't have a very good textbook for this. But hopefully, my notes, which should be available in PDF format shortly, that should give you good support for the concepts that I'm teaching, in my lectures. So yes, so Rajesh is asking if we can ask more questions. Yes, you can certainly ask questions even at this time. If you want, you can actually just type it in the chat box. I am seeing the chat box, so I can answer your question at this point. Jagdish, please confirm if I have answered all the questions, if there is anything that I need to, anything that I missed so far. Okay, it's not much activity in the chat box that I can see. And there's not much happening in the forms also. So maybe I've already addressed all the questions that you had. So if that is the case, maybe I can close this session right now. Like I said, this is just a continuing activity. Don't feel like if you missed this session, or if you missed asking a question during this session, don't feel bad about that, because we will have opportunities to discuss in the discussion forum, as well as, if you prefer, we can meet same time next week, or maybe some other time that you prefer. I'm open to that. So please come, keep communicating to us through the discussion forum. That will be the best way to understand what your expectations are as far as this course is concerned, and we'll, please give us an opportunity to address your requirements. Okay, so please keep communicating. So with that, let me close this session, and wish you the best for this upcoming assignment, which is due in a couple of days. I know week 1 is due in a couple of days, and week 2 assignment, the deadline has been pushed by a few days. I think February 7 is the deadline. You probably know better. But hopefully that gives you an opportunity to catch up with lectures, and try to do a good job on that. And any questions, we are more than happy to help you with that. Okay, thank you so much.